Okay, here we go. Second derivatives. Now, if we have f of x equals 3x cubed minus 4x squared plus 5x minus 6, the first derivative of this would be
9x squared minus 8x plus 5.
the second derivative would be
18x minus 8.
the third derivative would be
18.
the fourth derivative would be
0.
if second, third, fourth derivatives would be that simple, life would be easy. Okay?
Oh, no.
But Sal, he likes to ramp it up right from day one. Good old Sal. Okay? So, a second derivative, it might look like this. It might look like this. It might look like that. That's all notations for take the second derivative, people. Okay? So, let's look at some second derivatives.
Wait, so is that easy or is it not that easy?
It's not this easy, no. What I just did, I was just like, yeah, I was a big tease on that one. Okay? So let's look at the second derivative of 2 cosine of that. I would rewrite it as 2 cosine of 1/2 x, where u equals 1/2 x. What's du? 1/2. So if you take the first derivative of this, it would be 2 times negative sine of 1/2 x times the first derivative of the inside, which is 1/2, correct? What's 1/2 of 2? 1, so it's negative sine of 1/2 x. Now the second derivative of that, again, u equals 1/2 x, so du would be 1/2. What's the derivative of negative sine? It'd be negative cosine of 1/2 x times 1/2. So it should be negative 1/2 cosine of 1/2 x, which is choice B. Okay? All right. That's good enough. So do we have to do this one? Or are you good with sines and cosines? Okay. What? Okay. No, don't apologize for wanting to see it. Okay. So what's the first derivative of sine? Cosine. So this is negative 8 cosine of 3x over 2 plus 1 times the first derivative of the inside of that, which is 3 over 2. So then, before you try to take the second derivative, you need to simplify the first derivative. 3/2 of negative 8 is negative 12. Okay? Are we all right with that? That's the first derivative. Okay? Now let's do the second derivative. So the second derivative of negative 12 cosine of that would be the negative of that, which would be a positive 12 sine of 3/2 x plus 1 times the first derivative of the inside of that part, which is 3/2. 3/2 times 12 is 18. So it'd be 18 sine of that, which would be this one right here. Okay? If I see one like this, I'm going to rewrite it as 10 thirds x to the negative third. Okay? Now what's the first derivative of 10 thirds x to the negative third? negative 30 thirds, which is negative 10 x to the negative fourth. Don't put it down underneath because you need it up there to take the next derivative anyway. So leave it there. Now take the second derivative, which would be positive 40 x to the negative fifth, which is that one right there. Okay? All right. 2 to the x power. This is where it gets a little more difficult when they start throwing these at you. So that's when you get out your note card, because even I don't always remember exactly what to do. Okay? So if it's 2 to the x, it's 2 to the x times the ln of 2 times the first derivative of the power, which is 1. Okay? So that's the first derivative. You trust me? You're not writing anything on your note card. You're looking at it to figure out what the first derivative of this is. Now, what would the second derivative be? Well, we'd have to use the product rule there, Ricky. Quit playing snake and pay attention to what we're doing. All right, so the second derivative equals the product rule. So it's 2 to the x. What's the first derivative of the ln of 2? Why would it be x over 2? No, the ln of 2? Ooh, isn't that 0? Because isn't it, what's the natural, nice one. What's the natural log of x is 1 over x. But the natural log of 2 is like a number, 1 point something, 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 something. What's the first derivative of a number? Of that 1 point something, 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 0. Plus the first derivative of 2 to the x. Hey, we got to do that again. Or plus the ln of 2 times the first derivative of 2 to the x, which is 2 to the x times, again, the ln of 2.
What? Where are we getting that? Why are we adding?
Okay, product rule. The first times the first derivative of the second plus the second times the first derivative of the first.
So where'd you get the ln2? The second, the one all the way in the back.
Because we're taking the derivative of this. We just said the derivative of this was this, right? So when you take the derivative of this, it's this again. All right, so 0 times this cancels. So it's 2 to the x times the ln of 2 squared.
I'm still confused as to why the derivative of ln2 is 0.
So the second.
It's like a number. The ln of 2, punch the ln of 2 into your calculator. I bet you get a number.
How is ln of 2 punched into your calculator the derivative?
That's not the derivative. The derivative of the ln of 2 is a number. What's the derivative of up here? We said, well, the derivative of negative 8 was 0. The derivative of 5 was 0. The derivative of 6 was 0. So the derivative of the ln of 2, because the ln of 2 is like 1.256794876. First derivative of that is 0. Look at how much learning we do. Yes.
So if it's the ln of a number, it's always going to be the derivative of 0.
If it's the ln of a number, its derivative will be 0. Yes.
Just to make sure,
Mm-hmm.
the derivative of 2x is 2x times ln.
Mm-hmm.
That's okay.
Yeah.
That's where you're getting that from.
Yep.
I got it.
That's the derivative of 2 to the x.
But how do you How do you combine it if it's
ln of 2 times ln of 2 is 2 of them, so it's squared.
So what if you times? Do you not times ln of 2 times 2x?
It's being multiplied by that, but we can't multiply it to get anything.
You're taking the ln2 on the outside times ln2 on the inside. And
Yeah.
2x is on the inside.
Yep.
Just like reorganize.
Reorganize it. All right.
Yeah. No, they give it as like x times.
I just don't understand why you're not. I don't understand why you don't times because you have to like use the things, right? The same parentheses, right?
They give it like x times 3 times.
Look, I think it would help if you wrote like the d of x
Yep.
first, and then they would understand where you're getting this stuff.
All right. Let's do one of those again. Let's say we have 2 to the 3x plus 5 power. Okay, this one's a little more complicated. 2 to 3x plus 5 power. So, the first derivative of this is 2 to the 3x plus 5 times the ln of 2 times the first derivative of the top, which is 3. Okay, a little more complicated this time. Okay, so what I'm going to do is change the order. I'm going to go 3 ln of 2 times 2 to the 3x plus 5 power. Okay? And this is A and this is B. So if it's a product rule, you take A times the first derivative of B plus B times the first derivative of A. Correct?
Yes.
Okay. 3 ln of 2, if you punch it into your calculator, is some number, right? So, right now it's 3 ln of 2 right here. Times the first derivative of this is 2 3x plus 5 times the ln of 2 times 3. Right? Because that's the first, this is the first derivative, and this is A. And then we add on to it B, which is 2 to the 3x plus 5 power, that's B, times the first derivative of this, which is 0. So then that is nothing. And so this is 3 times 3, or 9 times the ln of 2 squared times 2 to the 3x plus 5 power.
Makes sense.
I'm right there. I'm ready for this AP test.
All right, let's do this one. Now it's a natural log problem. You guys can do natural log problems. All right, so it's 6. The first derivative is 6 times,
First derivative, right?
yeah,
1 over
4, so it's just 4.
4 over
I'm looking.
4x, right?
Hey, which one are you looking at?
This one. So what are you tweaking about?
Is that the first derivative?
Don't you the times it by 4?
Well, okay. Sorry, Trey. 1 and then 4. Yeah. 1 over u du.
Oh, okay, I got it.
That's why I was confused.
Yep, we're good. We're good.
See why? So how do we know that's not just log?
I didn't even put that one in.
Natural log of
No, I
x.
actually
Natural log of x.
If it's a natural log of anything but x, then you have to use your ln of u formula. Or what? Let me look at your note card. ln of f of x formula. Yeah. Yeah, because there's more than just an x there. So it's the ln of f of x.
So if it was ln of 2x,
Yep.
so the only way
Yeah.
would be the other one is if it was a 6 ln x.
Right. Yep. All right. Now, Okay, here we go. The 4's do what? Cancel. So the first derivative is really 6 over x, or 6x to the negative first. Correct? Now let's do the second derivative. It would be negative 6x to the negative 2, or negative 6 over x squared. Answer. Second derivative. Okay. That's the first section that you'll do of this. Then there's one more section of this stuff that involves like circles and hyperbolas and ellipses and other fun stuff like this. Okay? So this is a hyperbola question. What is the slope of the hyperbola at 8, negative 6? Is basically what they're asking. Well, let's figure it out, Nathan Ricky. So, what's the first derivative of this bad boy? 2x minus 2y dy dx. You guys are good. Equals 0. Woo. You're killing it. Now we get dy dx alone. So negative 2y dy dx equals negative 2x divided by negative 2y. So dy dx equals x over y. Okay. Now we're going to do the second derivative. Okay. So what's the derivative of x over y? It would be y, because it's quotient rule, times the first derivative of x, 1, minus x times the first derivative of y, dy dx, all over y squared. Now, this is a part, Nathan, Ricky, you'll have to take a break from your game so you can pay attention to this. What do we do with this dy dx right here? Well, what we do is replace dy dx with what is written right here. So this is y minus x times x over y squared.
You have to times it by x.
Whoa, what?
Like, because there's
X times x is x squared, yes. But
it's not x squared over yx.
no, it's x squared over y. Okay, now, Trey, we're not going to do that. Because right at this point, we're going to say, hey, x is 8, y is negative 6. So we're going to plug the numbers straight in right now. Negative 6 minus 8 times 8 over negative 6 over negative 6 squared. And we're going to find a number. Yeah, those are actual numbers instead of letters. We can actually work with this. Okay, so it's negative 6 minus a negative 64 over 6 over 36. That's a lot of sixes. Okay, so this is really negative 36 over 6 plus 64 over 6 over 36. Do you see where I got 36 over 6 from?
No.
Okay, negative 6 is 36 over 6, so we can get a common denominator in the numerator.
All right, exactly. Explain that one more time. How you got that?
I wanted to get a common denominator in the numerator, because this is negative 6 over 1 right now. So to get a common denominator, I multiply top and bottom of this by 6, so I get a common denominator of 6.
Actually, that does make sense.
Okay, negative 36 plus 64 is 28, correct? So it's 28 over 6 over 36, which is over 1. Now if we multiply by the reciprocal of this, And then 36, if 4 goes into each, we get 7/9.
Yes, of course.
Reduce the fraction. So it's 7/63. Oh, yeah. 1/9.
Oh, never mind. I get that. I didn't know what number it was.
I got it.
I still don't get. How did 7 over 9 equal 36 over 6? You see that 6 over 6?
Oh, I did. No, it's not 7/63. It's 7/54. Bushback. Jeez. 7/54.
Explain one more time where you got that negative 36 over 6. I still don't. Because on the top, yeah.
6 is over 1.
Oh, it's over. Okay.
6 is over 1.
I got it. That's on me, guys.
And then
That's the second derivative.
this is the second. This is the value of the second derivative at 8 - 6. And so, by knowing this, we haven't talked about concavity much yet, but by knowing this, since this is a positive number, the graph will be concave up at this point.
Yeah. Could you repeat that word again?
Concavity? If it was negative, it'd be concave down.
When you're simplifying it, why did you have to do it times 1/36? Like, why didn't you just go times 36 to these?
Clicks a little bit.
Like, why did you have to do all that extra?
Because this is 36 in the numerator. So
Yeah, but,
then,
like, why couldn't you just to get rid of the fraction just multiply by that?
no, you can't. No,
It's gonna be like this.
you're dividing.
Halfway through it. 10 grand in you.
Okay.
Oh, we're doing it again.
Oh, we're doing another one. Wild.
Oh, are we going on the harder side?
I
want to know how to do that, guys.
we're given this. We're given this. What is the second derivative? This is really a first derivative, isn't it? So the second derivative would simply be, because this is really 1 minus y squared to the negative 1/2, or positive 1/2. Sorry, 1/2. So the second derivative is 1/2 times 1 minus y squared to the negative 1/2 times the first derivative of the inside, which is negative 2y dy dx. Because this is the chain rule. This goes in front. This goes in front. You rewrite this exact same way, lower the power, and then you take the first derivative of the inside and write it behind it. Now, we know what dy dx is. So this is 1/2, and we get the square root of 1 minus y squared right there. It goes to the bottom, and with its 1/2 power inside square root. So on the top, we have 2y, and then we have dy dx, which is the square root of 1 minus y squared. Ooh. Dy dx is the square root of 1 minus y squared, right here. So we replace dy dx with 1 minus y squared. Negative 2y. Negative 2y, because that's the first derivative of the inside.
Can you cancel them out and just get -9 or negative y, or is that just like?
Nice. Okay, here we go.